Hey guys, leading up to this video, we talked about the law of sines and then separately the law of cosines. This video is going to talk about when you should use each of those and in what situations they're most applicable. All right, so just as a reminder, when we're naming a triangle, we're going to use capital letters to name the angles and lowercase letters to name the sides. So in the law of sines, we have that the sine of angle A over side A is equal to the sine of angle B over side B, which is equal to the sine of angle C over side C. So those are all ratios. We're not going to use all of them at the same time, but we can essentially use any angle and any side as long as we know the ones that are across from one another. We're going to use this specifically when we're given two angles and one side, or two sides and one angle, specifically in the SSA configuration, side-side angle configuration. We have two sides next to each other, and the angle is outside of those two sides. For the law of cosine, we have those big long equations. I'll let you read those. A squared equals b squared plus c squared minus 2bc over times the cosine of a, etc. And you can interchange whichever side is by itself along with which angle is by itself. This is what we're going to use when we're given two sides and one angle, just like in the law of sines, except it's going to be when we're given side angle side, when that angle is tucked in between the two sides that we're given. Or we're going to use it when it's three sides that we're given. Now, you don't have to remember which law you're going to use for any of these configurations. You don't have to memorize those. Law of sines is easier to use because it's one ratio instead of a long equation. If you want, every time you go to solve a problem like this, you can try to solve it with a law of sines. But if you don't have the right information, that's when you're going to switch over to the law of cosines. So this gives you an idea that there are certain circumstances where the law of sines is able to be used, where other circumstances it's going to be the law of cosines. But you can kind of figure it out as you go which one you're going to want to use. All right, so here's example one. The directions tell us to use the law of sines and or the law of cosines to solve each triangle. So the first thing you want to do is figure out, well, what do I have, and therefore which of the laws should I use? What I do is I come in here. First of all, we can say that we know we have two angles and we have one side. Since we know two angles, we can actually fill in that third angle. We know that the sum of the angles in a triangle is equal to 180. So if we add together 31 and 36, that's going to give us 67. And we're just going to subtract that from 180 degrees, which is going to tell us that angle B is actually equal to 113 degrees. So we can fill that right in. Now again, just as a reminder, the easier one to use is always going to be the law of sines. If we can use that, it's just an easier equation to use, easier to set up, easier to solve. So the question when we're doing that is, okay, an angle that I have, is it directly across from a side that I also have? And in this case, the answer is yes. Since we have a proportion of an angle to its side, that means that we can use the law of sines. That's the one we're going to use for this one. We know that we're going to be solving for side lengths. So what I'm going to do is I'm actually going to start with my side length in the numerator just to make it easier to solve. The equation that we're given has the sine of A over the side length of A, but we can flip those. These are all just fractions as long as we keep them consistent. So I'm going to start with 14 over the sine of 31 equals, now we're just going to fill in whatever side we're looking to solve for. So I'm going to start with the 36-degree angle. So that's going to be side C over the sine of 36 degrees. We want to solve for C, so I'm going to cross multiply. So C is equal to 14 times the sine of 36 over the sine of 31 degrees. So basically what I did is I wanted to get rid of this sine of 36 in the denominator. So I multiplied both sides by the sine of 36 degrees. So on the right, they cancel. And then over here, I'm just going to multiply through. When I do that out in my calculator, I have 14 times the sine of 36 over the sine of 31 to give me that C is equivalent to or equal to 15.98 feet. So now that side C, which is length AB, I can actually put up in here. So I've got 15.98 feet for AB, and I can fill in the angle B while I'm here, 113 degrees. All right, so I'm going to do exactly the same thing to solve for the other side that we're missing, which is AC over here, which is across from side B, so it's going to be side B. So same thing, I'm going to use that same ratio that I started with because it's essentially what I was given. I always want to use the information I'm given if I can. So I'm going to start with 14 over the sine of 31 degrees equals B over the sine of 113 degrees. To solve for B, I'm going to do the same thing that I did to solve for C. I'm going to multiply both sides by the sine of 113 degrees. So on the right, those will cancel. And on the left, I'm just going to multiply through. So that gives me the equation that B is equal to 14 sine of 113 degrees over the sine of 31 degrees. You can plug that all in on your calculator. When you solve it through, you get that B is equal to 25.02 feet. And I'm going to fill that in up here. Okay, so this is example 2, which is very, very similar to example 1. We are given the triangle, and we know that we're given 2 sides and 1 angle. Now, since we're only given 1 angle, that actually could go into either the law of sines or the law of cosines, but we have to ask ourselves, to use the law of sines, we have to have a side that is across from that angle. So if we look at this problem, angle R is 87 degrees, but we don't yet know what side R is. Since we don't know what side R is, we can't use the law of sines. We don't have the ones that go together for that ratio. So law of sines isn't going to work, which means we're going to default right to the law of cosines. All right. Now, again, you can use any of the equations that you want. If you want to remember each of them separately, that's totally fine, but we can just label our triangle to match up with what we have and what we need. So I just go back to that first one that's a squared is equal to, and we're going to use the cosine of angle A, which means that since I need the cosine of an angle, I'm just going to rename this triangle to make it easier. It doesn't matter which letter goes with which vertice. You just use the ones that you need. As long as they're all there, you're good. So a squared is the side that I'm going to solve for, which is going to be this one over here, equals, in this case, if I've labeled vertice P as B, side B is the one that's across, so 28 squared, plus C is the one that's across from angle C, 17 squared, minus 2 times, we're going to use 28 again, use 17 again. Cosine of the angle that we have is 87 degrees. Okay, so when we go through and we multiply all of that out and add everything, combine all the like terms, we get a squared is 1023.18. Take the square root of both sides, we get that a is 31.99 kilometers. Okay, so we've got our side A, which we can label here now as 31.99. But now we still have to solve for the 2 angles are the ones that we're missing now. So There's no need to use the law of cosines again. We can, because now we have all three sides, so we could plug them in and then solve for the cosine of each angle. But since we now have a side across from an angle, we have side A and angle A, we can use the law of sines, which is a whole lot easier, to help us solve for the missing angles, solve for one of them, and then do subtract from 180. So let's solve for angle B, or angle P in this case. So we know we're solving for the angle, so I'm going to leave the sine up in the top. So I've got that the sine of 87, let's start with what we know, sine of 87 goes over 31.99 is equal to the sine of angle P. We'll rewrite it back to P here because we don't need to worry about all of them. We're using one at a time, over 28. I want to get sine P by itself, so I'm going to multiply both sides by 28 so that these guys cancel, and then I'm going to multiply through. So sine of P is equal to 28 sine of 87 degrees over 31.99. Now remember, we want to make sure that these make sense. So I'm actually going to have you, instead of doing the arc sine of that whole fraction, you're going to multiply that through. We need that sine value to be somewhere between -1 and 1, or the angle doesn't exist. So we're going to say that the sine P, we're going to actually divide all those out. The sine P is going to be equal to 0.8741. Now, 0.8741 does fall between -1 and 1, so we know that so far this can work. So we're going to take the arc sine of 0.8741, meaning what is the angle whose sine is 0.8741? Remember, it's the arc sine, the inverse sine. So P, once you do that in your calculator, comes out to be 60.94 degrees. So here's where it feels like you're done and it feels like you can move forward, but there's a piece that we always have to remember to do when we're using the law of sines. We have said when we did that inverse sine, we said, what is the angle whose sine is 0.8741? Well, remember, if we have this angle of 60.94, the sine value is the y value, right? So what we're saying is that this y value is 0.8741. There is also, though, another angle in quadrant 2 that also has that same y value. It happens to have the same reference angle as the one in quadrant 1. That's also going to be 60.94. But what we have to find, though, is what is this whole angle, and would it make sense for that to be an answer? So since the x-axis is a horizontal line, we know that has a degree measurement of 180 degrees. Well, this angle that we're looking for is the whole 180 degrees less our reference angle, that is that 60.94. So to find what the other angle might be, we're going to subtract 60.94 from 180 to get 119.06 degrees. Now what we have to think about is, would it make sense for angle B to have a measurement of 119.06 degrees? Well, if we already know that we have an angle that is 87 degrees. If we add 119.06 to 87 degrees, we are going to end up with an angle that is greater than 180. If we add two angles together and they're greater than 180, that can't possibly work. So we can, even though we had to find it, we can eliminate the 119-degree angle as a possibility because of the information that we are already given. So we do know for sure that angle P is 60.94 degrees. The only thing left to find then is angle Q. So angle Q we can find by subtracting from 180, we're going to subtract the 87 degrees of angle R and the 60.94 from angle P. When we subtract all of those through, we're going to find that the measure of angle Q is 32.06 degrees. So we're going to take all those values and fill them in. PQ we found was 31.99. Angle P was 60.94. And angle Q was 32.06 degrees. 180. And here's example 3. If at any point you guys are feeling like you're comfortable doing these on your own, go ahead and pause the video, give the problem a try, fast forward to the end when I give you the final answer and check your work, and then you can always go back and see how I did things if you need to. But if you're feeling good, don't feel like you have to listen to this whole thing. So we'll go on to example 3. The only thing that's different for example 3 is that now we have to draw the triangle. These drawings don't have to be perfect. They don't have to be to scale, but if you can, it's going to make your life a little bit easier and it's going to make more sense to you if you can at least make them make sense. So I know that DE is my shortest side, is 6. And I know that DF, terrible triangle guys, sorry. DF is 18 and EF is 14. So I'm not to scale, it's not perfect, but it gives me the idea of what I have and what angles are going to be bigger or smaller. So in this situation, we're given 3 sides. We have our SSS triangle, which means automatically we have to go to the law of cosines. So it doesn't matter which one you're starting with, you can do any of them in any order. I'm going to write out that first equation that we always deal with. A squared equals b squared plus c squared minus 2bc cosine of a. So now I'm going to go in and instead of having these vertices be d, e, and f, I'm going to relabel them a, b, and c just to keep things straight. When I'm using the law of cosines with 3 sides, I find it easiest to solve for the longest side, or use the longest side, solve for the longest angle first. So since I have sides of 6, 14, and 18, that longest side of 18 means that my biggest angle is going to be angle E. That's the one that I like to start with. You guys can start with that, whichever one you'd like. So I've got A, B, and C. It's just going to make things consistent. So my side A is that 18 side. So I've got 18 squared equals 6 squared plus 14 squared minus 2 times 6 times 14 cosine A. So this is where it's a little bit different. Now I'm going to have constants on both sides, and I'm going to have to then find that inverse cosine of A. So 18 squared is 324 equals 6 squared is 36 plus 14 squared is 196 minus 2 times 6 times 14 is 168 cosine of A. My goal here is that I want to get this cosine of A by itself. I need that alone so I can take the arc cosine or the inverse cosine. So I'm going to subtract through. I'm going to subtract 36 and 196 from 324. So that leaves me with 92 equals negative 168 cosine of A. Still trying to get cosine of A by itself, so I'm going to divide both sides by negative 168, leaving me with the cosine of A is negative 0.5476. Now, having a negative cosine is okay. It just means that it's in quadrant 2 instead of quadrant 1. So this is the angle whose x value is negative 5476. This is totally fine and it works. So we're going to take that inverse cosine, leaving us with that A is 123.2 degrees. So now I can go in and label in my triangle that I've got 123.2 degrees for angle A. And what's nice now is that I have an angle measurement across from a side length, which means I can now jump into my law of sines, which is just easier. So if we wanted to solve now for, I'm going to go back to my original lettering. If I'm going to go back to side or angle D that I'm looking to search for, um, I'm going to say that the sine of D over its matching side, which is 14, is equal to the sine of 123.2 degrees over its matching side, 18. I want to get D by, or sine of D by itself. So to get rid of that, I'm going to, or sorry, to get that alone, to isolate it, I'm going to multiply 14 by both sides. So I end up with that the sine of D is equal to 14 sine of 123.2 degrees over 18. Solve that through, I get that the sine of D is equal to 0.6508, which is between -1 and 1, so that's great. I can take the inverse sine of both, so D is equal to 40.6 degrees. But again, remember, there are two places where we have this sine value of 0.6508, the y value, here and here. So to find out what our larger angle is all the way across, I'm going to subtract my reference angle, the same one that's on this side. So I'm going to subtract 40.6 from 180 to give me another angle, another positive 39.4 degrees. But right away, we know that that's not going to work because we already found that angle E was 123.2. And now to say that angle D is 139.4, we know that that's not possibly going to be able to work. It's way over 180, so we can eliminate that altogether. So angle D is 40.6. Now I've got two angles. I could go back into the sine, the law of sines, but again, we don't need to. Once we have two angles, we're just going to add them together and subtract from 180. So that leaves us with, actually change this back to angle E. So 180 minus 123.2 minus 40.6 is going to be the measure of angle B, which is, sorry, angle F. Let me be accurate with that. F. Angle F is equal to 16.2 degrees. So now I can fill in all of those. I've got 40.6 degrees, 123.2 degrees, and 16.2 degrees. Okay, so this is the last of these examples. So if you have not yet given one of these a try on your own, please do so, and then come back and check your work. So again, for this problem, we have to draw our own triangle. So I know that side xy is 15. I know that xw is 9. What I don't know is wy. So again, this could be drawn completely wrong. It could be that wy is my longest side. I'm just giving it my best guess. As long as your labeling is right, don't worry too much about the scale. I also know that angle W is 31 degrees. First thing I want to look at is, do I have an angle across from a side? And in this case, the answer is yes, which is awesome. Since I had that, I can jump right into the law of sines. What I'm going to try to find first is angle Y right here. So I'm going to say that this, since I'm looking for an angle, I'm going to have that on top. The sine of 31 degrees over 15 is equal to the sine of Y over 9. I want to have the sine of Y by itself, so I'm going to multiply both sides by 9, which gives me that the sine of Y is equal to 9 times the sine of 31 degrees over 15. Remember, do that out. We want to make sure what we have makes sense. So the sine of Y is equal to 3090. It is between -1 and 1, so I'm good. I can take that inverse sine of y. Y is equal to 18 degrees, but don't forget the sine of y. That y value, the sine value, does happen twice, both in quadrant 1 and 3. So I subtract 18 from 180 to give me the other possibility as 162 degrees. Now if I add 31 to 162, that's going to give me 193, which means that this angle is not possible. It doesn't work. So I know that the sine of y has to be 18 degrees. So I'm going to go, or sorry, that angle y has to be 18 degrees. So I'm going to go ahead and fill that in right away. Now I know two sides and two angles, but so I need to find, I'm left trying to find angle x and side x. Now, the problem here is that we don't have a side across from, sorry, an angle across from that side. We need that, but we can find it pretty easily. Now that we have two angles, we know that the total angle measurement, interior angle measurement of a triangle is 180. So that makes it that angle x has to be equal to 131 degrees. I'm going to add 31 and 18 together, and I'm going to subtract it from 180 to show me that angle x has to be 131 degrees. So I'm going to even fill that in right now. So now I can use those angles and I can solve for the side. So I'm going to have that x over the sine of 131 equals, I always like to go back to the ones that I have, because then if I've calculated wrong in another part of the problem, I don't have to worry about this answer being wrong because of it. So I'm going to use that angle w and side w and solve for angle x. So to get x by itself, I'm going to multiply both sides by the sine of 131 degrees. So those sine of 131 cancel each other's out. I'm left with x equals 15 times the sine of 131 over the sine of 31 degrees. When I solve all that through, x is going to be equal to 21.98 meters. So now I can fill that in up top. Wy equals 21.98 meters. Don't forget your label. The other kind of problem that can go along with this law of sines and the law of cosines are some application problems. Often you're going to see it's in relation to how far places are apart, how far things are apart, directionality, those kinds of things. I think the hardest part in these kinds of problems is actually drawing the picture of what they're talking about. So in this problem, it says that Cincinnati, Ohio is 540 miles due east of Kansas City, Missouri. The bearing from Kansas City to Nashville, Tennessee is south 64 degrees east. The bearing from Cincinnati to Nashville is south 29 degrees west. So what, right? So I think the easiest way to go about this problem, instead of dealing with Cincinnati and Kansas City and Nashville, I'm going to label each of these as a letter, as a point. So Cincinnati is going to be A, Kansas City is going to be B, and Nashville is going to be C. Not for any reason in particular, just it's the order they popped up in the problem. So let's draw the problem. The easiest one to relate are Cincinnati and Kansas City, or points A and B. We know that Cincinnati, Ohio is 540 miles due east of Kansas City. So that means from one city to the other, we're just going to go straight in a horizontal direction, straight east/west, depending on which way we're talking. So I'm going to start by drawing my vertical line here. Actually, I'm going to get myself a little bit lower. So here are my 2 points that are 540 miles apart. Now, Cincinnati, Ohio is 540 miles due east of Kansas City. So don't forget, we've got north, south, we've got east and west. So due east means that Cincinnati is over here on the right and Kansas City is over here on the left. Due east, we go directly to the left, to the right from the left. Now it says the bearing from Kansas City to Nashville, Tennessee is south 64 degrees east. So what that means is if we draw a vertical line here, and a vertical line here because we're doing Kansas City first. So if I draw my vertical line through Kansas City, south 64 degrees east means from due south from down here, the bearing from one city to the other is 64 degrees. The problem is that measurement doesn't help me, right? But I know that if it's 64 degrees, we're basically creating a right triangle here. So if the bearing is from my vertical line 64 degrees, that means that inside the triangle is 26 degrees because they're going to add up to 90 degrees. That's going to make a 90-degree triangle. The bearing from Cincinnati, which is over here, it's my A point, from Cincinnati to Nashville is 29 degrees south, 29 degrees west. So again, I'm coming down south, and then I'm going to the west, which is to the left, 29 degrees. So from my vertical line to the angle, this is 29 degrees. But again, it's not in my triangle. It doesn't necessarily help me. So what I have to do is figure out, well, what's my interior angle? What I've created here is a right triangle. So I know when I add those together, I get 90. So inside has to be 61 degrees. Okay, so now I have two angles and I have a side. What's nice when I have two angles is that I can automatically find the third. So the interior angle measurement of the entire triangle is 180. I'm going to subtract from that the 26 degrees and the 61 degrees, which means that my angle C here has to be 93 degrees. So now I have all three, and as long as I have all three angles, what's great is I automatically have, as long as I have one of the sides, I have a side that is across from an angle. So I can use the easier of my two laws, the law of sines. I'm going to be solving for a side length, so I'm going to put that 540 on top with the sine of 93 in the bottom. That's what I'm going to use for my ratio. We are looking to, in this problem, find the distance from Kansas City to Nashville. So Kansas City was my B to Nashville, which is my C. So I'm looking for side A because it's across from angle A. So I'm going to say that that is A over the sine of 61 degrees because that is the measure of angle A. I'm going to solve for A, so I'm going to multiply both sides by the sine of 61 so that they cancel. So on the right, so A is 540 sine 61 degrees all over the sine of 93 degrees. Once you put that in your calculator, you're going to solve for A, and that distance is 472.94 miles. Okay, and here's part B of this problem. So we're still using the same picture, so I've copied and pasted that over here. We're still using the same locations. I've rewritten the A, B, and C for our points. And now what we're trying to do is find that distance from Cincinnati, which was our point A, to Nashville, which is point C. So we're essentially looking for side B. All right, so in solving for side B, since we still have the side that is across from the angle, we can still use the law of sines, which is great, much easier. So again, I'm going to set it up. We're solving for a side, so I'm going to put the side that we have on top over the sine of its corresponding angle. So 540 over the sine of 93 equals B over the sine of 26. So B is equal to, we're going to multiply both sides by the sine of 26 to get B by itself, 540 sine of 26 degrees over the sine of 93 degrees. Put that all in your calculator, and you end up that side B, or the distance from Cincinnati to Nashville, is 237.05 miles. Again, don't So we have one last application problem. This one says that leaving from the same port, ship A sails 8 miles at a bearing of north 45 degrees west, so meaning north of the equator, and then to the west, which is the left. And ship B sails 14 miles at a bearing of south 70 degrees west. So we would measure that to go straight down, and then west is left as well. So we're going to go to the left 70 degrees. So again, application problems, I think part of the hardest part is actually just drawing the picture. So we're going to do that first. So leaving from the same port. So we've got them both leaving, we'll say right from here. Ship A sails 8 miles at a bearing of north 45 degrees west. So just to make it a little bit easier to see, here is my north-south line of reference. So ship A sails 8 miles at a bearing of north 45 degrees west. So 45 degrees is about this direction. Here's my 45 degrees. And they sail for 8 miles. Since we're working with the law of sines and the law of cosines, I don't know yet. I know I need a triangle, but I don't know exactly what that's going to look like yet. So I'm going to keep going, writing in what I know, and then I'll figure out what I need to know from there. So the second part of this says that ship B sails at 14 miles with a bearing of south 70 degrees west. So to figure out which direction that is, instead of north, which I did the first time, now I'm going to go south. And instead of drawing straight south, I have to be 70 degrees away from that south, the southern measurement. So I'm going to draw my angle this way and say that here is my 70 degrees. It is 70 degrees away from that vertical line showing me due south. Well, now I can see where that triangle is. And the problem is I don't have an angle for either one of those to help out to make the angle of either one of those triangles or any vertice of that triangle. So what I'm going to have to do is figure out what my measurement here is. So you've got a couple different ways of looking at it. You can say that we know we have a vertical line that includes this 45 degrees, the 70 degrees, and then the angle that I'm missing in here. Or you can relate both the 45 and the 70 to their 90-degree counterparts, which is here and here, and solve for them separately. Either way is fine, but what you're going to find if you were to do it that way, you've got that this angle is 45, you've got that this angle is 20 degrees, which means that this whole angle, which is actually what we need, is 65 degrees. So what this question is asking me is how far apart are the two ships? So that is this length right here between A and B. So what we have now is we know that ship A sailed for 8 miles, so we have one side. We know that ship B sailed for 14 miles, so we have two sides. And then we know that the angle actually between them is 65 degrees. So we have two sides in an angle, which could be either law of sine or law of cosine, depending on what we have. The problem is the one angle we have is across from, we're going to call this angle or side C. We'll make this angle C, and this is side C. And we don't have side C. We don't have an angle and a side that go together. So this means we're going to have to use the law of cosines. What I'm looking for is C, and the angle that I have is C. So we're going to say C squared is A squared plus B squared minus 2AB cosine C. Fill it in. So C squared is 14 squared plus 8 squared minus 2 times 14 times 8 times the cosine of 65. We'll just keep filling everything in. So 14 squared is 196, 8 squared is 64, 2 times 14 times 8 is going to give me 224 cosine of 65. If I add together 196 and 64, so C squared is 260 minus 224 cosine 65. C squared. Now I'm going to go through and actually put all of that in my calculator. C squared is equal to 165.33. And C is therefore equal to 12.9 miles. Don't forget those labels. All right, last problem. So for this question is saying it's the same situation we had in the last one. This is just part B. So now it's asking, instead of how far apart they are, the two ships, it's if ship A were to sail to ship B, what bearing would it take? Now remember, bearing is if we were to draw a vertical line, um, we're relating north and south to east and west. So we know that B is south of A. So we know we're going south, right? We also know that the angle is to the left of that vertical line. So we're going to be going to the west. Remember, never eat soggy waffles. So that means it's some angle measurement to the west of that southward bearing. So what we're really looking for in this problem is not all of angle A, it's this piece of angle A, which makes it a little trickier. What we know, however, from the original problem, we've got a right triangle up here. We know that this is a right triangle that's created. If this angle measurement is 45 degrees, that means that this angle also has to be 45 degrees, which also means that this angle has to be 45 degrees. So if we can solve for angle A, all we have to do is subtract this 45-degree piece to give us the angle for the bearing that we're looking for. So that's what we're going to do. We are trying to solve for angle A. We now have a side, because we solved that this was 12.9, we have a side across from an angle. So now we can use the law of sines, which is great. We're solving for an angle, so I'm going to have that angle measurement in the top in the numerator. So I'm going to say the sine of 65 degrees over 12.9 equals the sine of A over 14. Multiply both sides by 14. So I'm going to have that the sine of A equals 14 sine of 65 degrees over 12.9. Solve that through, and that is going to give me a value of 0.9835. That 0.9835 is between 1 and -1, or -1 and 1. So I can go ahead and solve that A is equal to 79.6 degrees. Since angle A is equal to 79.6, remember we said in the very beginning we're going to subtract 45 degrees from that because we're trying to get rid of this side of the angle to just give us the bearing angle. So I'm going to take 79.6, I'm going to subtract 45 because that's the part of that 90-degree angle that or the part of the angle that we know we have that we don't need, to give me 34.6 degrees. And so we're going to fill this number in to our bearing. So our final answer is actually going to be that the bearing should be in the southern direction, 34.6 degrees to the west. And that is your final answer. Thanks, guys. Have a great rest of your day.